Hey everyone, so today I'm going to talk about the tournament problem and I will try to give you a very nice or you can say a very elegant solution to this problem. So let's try to see what is our problem. So the problem is this. So suppose you are an organizer for an event. So you are planning to organize one event and in that event there will be some number of matches. So question is, if suppose n number of teams participate in that tournament, suppose 1000 teams or 10,000 teams, question is, and it's an knockout tournament, then the question is how many matches you should conduct to get the winner or to get the champion. Okay, so that's what my question is. It's a simple question. Solution is also very simple. I will give you two methods to prove that solution. Okay, and the second one is a very nice solution which I personally very liked. So what is the scenario? So since it's a knockout tournament, so scenario is at each round you will pair up the team. So team 1 and team 2, that will be one pair, team 3, team 4, that will be another pair, and then you will conduct a match between those teams. So and the winner will go to the next round. Suppose if there are even number of teams, you can easily do the pairing. But if there are odd number of teams, whichever team is left off, you will give them a bye. They will automatically go to the next round. They will no need to face any match because there is no opponent. Okay, so if there are even number of teams, you pair them off, you take a match between them, winner will go to the next round and the loser will be out of the tournament. And if there is only one team is left, that means if a team do not have any opponent, it will automatically get a bye and it will go to the next round directly. So these are the rules of our tournament. So that's why I have given the name knockout tournament. So the question is how many matches you should conduct. Okay, let's take a very simple case before giving you the direct solution. Let's take a simple case. Suppose if there are some 100 teams which are participating in the tournament. 100 is a nice number. So what is the first thing we will do? We will first make 50 pairs, right? Say team 1 and team 2, team 1 and team 2, that will be one pair, then team 3 and team 4 another pair. In this way you will be having 25 pairs, right? So you will have you will be having 50 pairs. So for this 50 pairs you will conduct the match. So you will be conducting how many matches? You will be conducting 50 matches. We will have 50 winners, 50 losers. Losers will go home, 50 winners will remain. Now among these 50 teams now, you will again pair them up. So how many pairs you will get? You will get 25 pairs, 25 to the 50, right? So now you will conduct 25 matches to get the winners. So now in this 25 matches you will get 25 winners and 25 losers. Losers will go home and the winners will go to the next round. Okay, now you have 25 teams. What you will do? You will make for this 25 teams, how many pairs you will have? You will have 12 pairs, right? 12 to the 24. And the one which is left over, that team will automatically go into the next round. Why? Because of our second rule. That's what our second rule says, that that team will get a bye. So now there are 25 teams. I will make 12 pairs. So 24 teams will come into this pair and one team will automatically go into the next round. So here I will be conducting 12 matches. Okay, so now how many teams I am left with? I am left with 13 teams, right? Because from here I will get 12 winners and one team got a bye. So now I have 13 teams. Now for again this 13 teams, I will make 6 pairs. 6 to the 12 and the one which is left, that will automatically go into the next round. So here I am conducting 6 matches. So now how many teams are there? Now 7 teams are left, right? Because from this 6 pair I will get 6 winners and the one team which automatically went into the next round. So I have now 7 teams. For 7 teams I will have 3 pairs. So 3 to the 6. Again the one team is left which will go to the next round. So I have to conduct 3 matches for these 3 pairs. So now how many teams I am left with? I am left with 4 teams. Because from these 3 pairs I will get 3 winners and one team which was there, that will go into the next round. So now I have 4 teams. So for these 4 teams I will have 2 pairs. So I have to conduct 2 matches and finally I have 2 teams finally. Among them, if I want to get the champion, I have to conduct 1 match. So these are the number of matches I will need to conduct. So if I add them up, this is 9, this is 9. So if there are 100 teams in a knockout tournament, you will need to conduct 99 matches to get the champion. So I hope this was clear. Okay, now suppose 1,000 teams turns up for your event. So your event is it's a hit now. So now suppose 1,000 teams arrives for an event. Question is how many matches you need to conduct. Let's do the same thing. You first make a pair. So you'll have 500 pairs. So we'll conduct first 500 matches to get first 500 winners. Then next we'll conduct 250 because 250 into 2 is 500. So we'll conduct 250 matches. 150, half of 250 is 125. So we will conduct 125 match to have first 125 winners. Then out of this 125 you will then conduct 62 matches because 62 into 2 is 124. And the one which is left, that will automatically get a bye because odd number will get a bye. For this 62 now again, if I keep on doing this, I get 31, 16, 8, 4, 2 and at the end 1. And if I add all of them, I will get 999. So we took two examples. When if there are 100 teams, we will need 99 matches. If there are 1000 teams, I will need 999 matches. And if you are a very optimistic person like me, what you will make a conjecture? You will conjecture that if there are n number of teams in the tournament, if it's a knockout tournament, then you will need n minus 1 number of matches to get the champion. So that's what I have conjectured by looking at the two examples. And then one way to prove this is, and actually it's a correct conjecture, one has to prove this. So since this is indexed by natural numbers, because n is what? It's a positive number, n can be 1, 2, 3, 4. So whenever we see any statement which is indexed by natural numbers, we always try to prove by induction. So that you can give a try. That's a very straightforward way to prove. But let me give you a nice solution which is nothing but in terms of sets. So what I will do is, I will take two sets and then I will try to give a bijection between those two sets. So suppose if this is a set A and this is the set B. Set A and set B. What is set A? Set A is nothing but, okay, if you have observed till now, the winning team, let me call that winning team as the champion team. So that is the champion team is the only team which will not lose even a single match, right? Because if it is that team is becoming a champion, means what? It has not lost a single match at the end, till end. Okay, so champion team is the only team which will not lose a single match, whereas all the other team will lose exactly one match, because as soon as it loses a match, it goes out of the tournament. It do not have a chance to play another match. So that's a very keen observation for this. So what is A set? It is the set of teams except the champion team or the winning team. So what is cardinality of A? It is n minus 1, right? Because out of n teams, I will not consider the champion team. So how many elements does the set have? It will have n minus 1 elements. So set A has n minus 1 elements. The elements are nothing but the number of teams. Oh, the elements are nothing but the teams. Okay, so team 1, team 2, team 3 up to team n minus 1. So this is my set A. Now what is my set B? My set B is nothing but, so B has, so what is B? The elements of B are nothing but the matches. So my question, so our aim is to find what is cardinality of B. So what will be the cardinality of B? It is the number of matches. It is the number of matches that is going to be played in the tournament. So this is what my aim is. I want to find B. Now as we know the answer that there are n minus 1 matches has to be played. So ultimately what I have to prove? I have to prove that cardinality of A is same as cardinality of B. That means what? I am going to define a bijection between these two sets. Right? So how will I define a bijection? So this is match 1, match 2, match 3 and so on. Okay. Now how do I define a bijection? That is the question. You take a team from here. You will map this team to where? So since a team will lose exactly one match, you will take a team, you will map this team to that match in which it will lose the match. Okay, so team, you take whatever team T, it will map to that match. So in this match, T loses. And this is a well defined map, right? Because a team will lose exactly one match. As soon as it loses, it goes out of the tournament. So it's a well defined map and it's a 1-1 map. And on the other way, from here to here, how will I define a map? You take a match here M. In this match you see who is the loser and you will map this M to that loser team. And so since for every match there is exactly one loser, so this is also a well-defined map. So this is what I have. I have a bijection between the number of teams except the champion and the number of matches. So you map a team to the match it loses, and this way I have a bijection. And we know that in bijection, if two sets are bijective, that means what? They have the same cardinality. So since cardinality A has n minus 1 element, A has n minus 1 elements, our B also has n minus 1 elements. So that's what the answer is. I like this solution very much. That's why I thought of sharing with you. So now you can easily tell me, right? So now suppose if you have a tournament, suppose in where 3, 2, 4, 6 teams are registered, and now you know exactly how many matches you need to conduct, which is nothing but 3 to 4, 5. So you need to conduct 3,245 matches to get the winner. So I hope you like this video. See you next week with one more interesting video. Thank you and have a nice day.